most likely component to fail in any computer or storage device is the moving part, which is the hard drive that's spinning anywhere from 5,400 to 15,000 rotations per minute. RAID, which stands for Redundant Array of Independent Disks, is a redundant system that uses multiple hard drives to store your data, so that even if one drive fails, your data is safe and accessible. Redundant systems are used in all kinds of critical applications where failure would be disastrous, such as aircraft control systems. Similarly, a redundant disk system could save your business from critical data loss and therefore should be considered as part of any data protection scheme. Let's start with some common RAID terminology. First, mirroring. This is where multiple disks contain identical data. Second, striping. This is where sequential blocks of data are split among multiple disks. Finally, fault tolerance. This is where parity data is stored, allowing data to be recovered if a problem is detected. Now let's review the different types of RAID and understand the benefits of each type. First, RAID 0. Data is simply written to multiple disks as if they were one using striping. This is done to improve performance by transferring data simultaneously to multiple disks. If one of the drive fails, all data is lost. The usable capacity of this is roughly the same as the physical capacity of the drives. Now be careful, this offers no additional protection. It's all about the speed. So RAID 0 is not recommended for data protection. Next, let's look at RAID 1. This utilizes mirroring, so the same data is written to two drives. If one drive fails, your data exists and is readily accessible on the other drive. The usable capacity will be roughly half the physical capacity of the drives. For example, if you have two drives that are 1 terabyte and set up for RAID 1, then you will have only 1 terabyte of usable capacity. Next, RAID 5. Data is written across all the drives with extra information called parity, such that your data can be retrieved if any one of the set of drives fails. A RAID 5 storage device requires a minimum of 3 drives. The usable capacity will generally be the physical capacity less 1 drive. So if you have 4 1 terabyte drives, there will only be 3 terabytes of usable capacity. Next, RAID 6. Just like RAID 5, data is written across all the drives along with the parity information, but has double the parity, such that your data can be retrieved if 2 drives fail. A RAID 6 storage device requires a minimum of 4 drives. The usable capacity will generally be the physical capacity less 2 drives. Lastly, let's look at RAID 10. It's a combination of RAID 1 and RAID 0. In this case, data is mirrored and then striped across all the drives. The usable capacity is roughly half the physical capacity of the drives. The iOmega Store Center family of network storage solutions blends award-winning EMC storage and security technologies with easy-to-use configuration and management tools, purpose-built for small businesses and remote offices. Learn more about network storage solutions at www.iomega.com/NAS.